I don't think if there are still places over here, but hope at the back you also feel comfortable. We're pretty much packed, but I think it's still fine. People are showing thumbs up, so should be fine. It's actually probably the biggest React Amsterdam meetup we ever had. It's just like the full hall, it's insane. We had like around 260 RSVPs that then scaled up to 230, but it's still insane. I haven't expected to have so much people here, so you hope you all enjoy it, all the talks. So we'll start with the short introduction, and then we'll have 4 talks. I'll show the agenda slightly later. The 2 first ones would be about Cross-env Redux actions, which is basically referring to logux or logux. Andre will correct me and say it multiple times after me, so you can remember the right pronunciation. So my name is Robert. If you haven't saw me before, I'm organizing React Amsterdam Meetup conference, co-organizing Amsterdam JS Meetup and organizing conference, and lots of other things. I work as a tech lead at Zuber as well, so basically this is a side thing we're doing with meetups to stay as close as the community and still have like hands-on development and to feel how good are the meetups or how bad they can become from the other side. We're live streaming the event, so we hope that everybody can always tune in, even if somebody didn't fit into the hall or just couldn't join because of personal reasons or the weather. All the talks are streamed and available straight away on the next, well, basically after the event is over, the recording is available straight away. And then we separately edit the videos, so you can also watch fine-tuned version of each specific talk or share it with your friends if you like today's evening. Then, of course, the professional venue like this and the food, the drinks, the video setup that we always have a lot of stress before the start of the event wouldn't be possible without our supporters. So one of the newer supporters... It's fine. It's a mute button on. So one of the newer supporters that will be with us at least for 4 meetups is Evolution Gaming. They recently relocated or opened a new office in Amsterdam. It's a global company, so they have lots of offices around the world. And they asked also to show like a small demo of what they're actually doing, at least in the Amsterdam location. They're doing WebGL casino games or the platform for the other casinos. So really focused on the 3D graphics and stuff like this. And also we have other sponsor also helping us out for multiple meetups already, which is basically a job board for developers. Probably you already heard about it, but if not, it's a good opportunity to check the market, what's happening. And if you're looking for new challenges, you can basically go through there and choose something that is more appealing to you. So as I said, the meetup we're organizing here is probably the biggest, not only for our group, but also probably one of the biggest JavaScript groups in Amsterdam in general. I actually don't know any other JavaScript meetup that's, or JavaScript related meetup, which could host like 200 plus people as we have today. Also out with other achievements and highlighting the other achievements we had last year or last season, because season for us, for the event organizers, is starting basically from like September or from today, as this is the opening meetup, till end of autumn and start of summer. So basically, last season was super successful. We've been growing in numbers in meetups and conference. We actually also suddenly became a biggest React conference as a React Amsterdam conference 2017. We had 1,200 visitors, which is just insane. This was slide prepared for the MCs that were opening the conference, but then we recounted numbers a bit, and it turned out to be 1,200, which is just also crazy because we initially been aiming only for 500. Yeah, some slide here just for good memories. More than 300 people engaged, a lot of RSVP'd that won't come, probably because also give some place for people on waitlist, which also had like up to 20 already in a row. And again, why I'm repeating those numbers, because it's like super exciting. It's really great to have such a big audience, because with that we get more speakers, we get more engagement, and it's becoming more and more interesting, and which is super important for us doing this as a part-time activity. without growth, it will be a lot more boring. On the other announcements, apart from some events we do in Amsterdam, we also help out right now with the React conference in Berlin. So if you're not enough with React on our meetups or with annual React Amsterdam conference, please consider React Day Berlin. It's also a one-day conference, fully packed with lots of talks. It's also basically a community event with lots of people from Berlin and also from international, from other countries. And also we have a special discount code, so you can save some money for today's after party, which we'll have, by the way, in the bar opposite, basically across the hall in the Korea Cafe, which, if I'm not wrong, is open like till 11. So feel free to just hang out after the talks, and we highly encourage that because we'll also stay to talk with you and get some feedback. So if you use React Amsterdam code, you will get a discount on reactday.berlin. It is a 20% discount, so it's quite valuable, I'd say. And as probably, if you're following us on Twitter, which is basically @ReactAmsterdam, as we're everywhere, we recently announced the React Amsterdam 2018 conference, which will again happen in April. The date is set, it's April 13th. It will be also a Friday 13th. So I don't know who's afraid about numbers, but we're confident that it will be, again, really great event and a lot better definitely than previous, as we aim only for the growth. And we'll have some like topics for like with horror stories. I heard previously on the previous networking event that people wanted to hear some fail stories from other developers to see how they didn't accomplish some goals, how technology failed. So we'll have like a horror section as well on the conference, which should be fun. And also the after party of the event will be themed around that a bit to make it a bit more unique and add some fun next to the talks. And actually, the super early bird sales starts just right now, although we've been a bit late. Right now it's 19 and at 7 and 10 minutes. Basically, the early bird ticket sale started. And we have a really limited supply, so if you are really interested in shaving off some deal there as well, you can grab your phone and basically grab the most cheapest ticket we will have, because the next releases will be also growing in prices. We expect that actually those tickets will be sold till the evening, but probably after on the break there will be also still some space. And yeah, as I mentioned, this is basically an opening event for the next season, for season of 17 and 18. And we already actually planned also the next meetups. We have like agenda for the full year. Next React-related meetup, React Native meetup, will happen in November. If I'm not wrong, it's 15th of November. So if you're into React Native, then definitely join it as well. We have some speakers that will present there also here today, like Narendra. So you can also pitch him new ideas to change the presentation if he's still open for that. And yeah, Amsterdam Jazz meetup also will be happening in the same hall, and the date is also set. It will be 7th of December, so don't miss that. We also expect to have a really great meetup with lots of attendees and lots of great talks. And probably I will be now putting this guy on every slide of the introduction, because we want to have as much as input and engagement from the community. This is photo from React Amsterdam, by the way, of the React Amsterdam conference, by the way, from last year. And basically, why I'll be always repeating that, because we always have some spots on the stage. This time we have 4 talks. We can actually fit even more small lightning talks, as it also was by feedback in favor by the attendees. So we really want to get as much talk proposals as possible. So to make it easier to stand up and speak about your experience, which could be also like a horror story, like a fail story, success story, or whatever, anything that you feel could be somehow interested, just submit your talk into our forum. We have links to those forums in the event page. I'll also put it into the comment section in the meetup description. And we welcome talks of 30 minutes, of 5 minutes, of 3 minutes if you like, if you have like really short page, but it's interesting and you feel you need to share it. We're open to multiple different formats of talks. And we have enough volunteers right now that will help you to master your skills. So if you are not experienced but still have an interesting idea, throw your talk into the submission form, mention that you need some more assistance, and our volunteers and people who have really great experience in talking on different international conferences will have video sessions for you, will coach you, and will help you getting to the field and getting to the stage as well with a really successful talk that everybody will like. And also, we have usually a pitch session. I've been mentioning the fact that after the 2 first talks, there was a possibility to stand on a stage and pitch some ideas, like a real short talk. Basically, to apply for that, you need to reply to one of the emails we've been communicating from the Meetup group. Usually, I send all of them, so if you reply directly to me. And basically, you can book the spot to have your lightning super short talk or something like this. And again, a gift to encourage you doing the submissions, because we really get not enough submissions, and we really want to engage more developers, as this is a community event, and we don't want to have like companies pushing developers instead of community proposing their ideas. There's more gifts. I can continue with those if you want until you will submit the talk, but I hope that at least like, I don't know, 10% of you, if 10% of you will submit and do the talk on next React Amsterdam, that would be super awesome. So, without taking too much time, the agenda for today, we're late for like a few minutes, it's fine. 4 talks, short break in between. So in the break, you can run to the toilet or grab some beer before the second part of the session. And around 8:30, we'll have like after party officially starting at Korea Cafe right across the hall. And of course, follow us on Twitter or Facebook, non-intrusive social news channels where we push all the talk announcements and video recordings are there. So if you miss some event, you will never miss a talk recording of some interesting topic that we'll be announcing through the social media. Right, and that's it from my side. Now I will welcome Andrei Sitnik on stage. You can applaud, yeah.
Вот здесь кнопка. И кликер. Он будет работать? Hello, everyone. The name is Lagax, not Logax. And yeah, my name is Andrei Sitnik. I'm from Russia. I'm lead front-end developer in Evil Martians team. But you may know me as creator of Auto Prefixer, Post CSS, and browser list with cute logotype. But today I will talk not about CSS problem. There is other problems, because it's like React Amsterdam, it's not CSS Amsterdam. So yeah, it will be a talk about JavaScript. And we have a big problem in JavaScript. So let me explain. But I'm start from different part. Like my family live in China. You know, everyone like to visit your family, to eat borscht from your mother, everything else. But there is one problem for me to visit my family. It's Chinese internet. It's not really a censorship, because like censorship could be fixed by VPN. The real problem is that half of the packages is lost in Chinese censorship system. Even if packages was to a legal website, they just cut half of the packages. It's like a local company promotions, because there is no that cut for local websites. So internet is not really good. Like imagine how your site will work on this internet. But you know, like China, it's not my problem. It's like some second world. But technically, the problem internet is anywhere. Like New York, like the center of our civilization, and they don't have internet in the trains. They only a year ago got internet to got Wi-Fi on the stations, but like it doesn't help you because Wi-Fi is very slow. Wi-Fi connection is very slow. On the time when train will stop, you spend a lot of time. Or for example, like who was on the .css, .js, .ii conference? No? Yeah, you know that they have one of the greatest, one of the beautiful venue in the world. But unfortunately, in this venue, they don't have any Wi-Fi, and mobile signal is extremely slow, extremely low. And so like there is no internet on the on the computer science conference. Okay. So, internet is always unstable. If you have a wireless internet, it will be always unstable by definition because it's how wireless works. And this is why offline first is so important. Offline first is important not because you can go to some mountains, hiking and all this stuff, but because we have, how you call it, 1 second mountain in our cities. Just because your Wi-Fi becomes slow or like internet connection or mobile connection doesn't work in this house. And this is a problem. This is a problem because at least I create a website for internet like this, because this is internet that I have on my machine. Because like I have a local server, local client, no problem. But unfortunately, the real internet looks completely different. And often we forgot to test our site, to like check how it will work on this type of internet. And there is a lot of problems that I saw on any websites like around the world, and the problems that I have on my websites. First, like if you make a JAX request, and it will be some problems, like it will be broken, the loader will be loaded infinitely. In the many websites, they doesn't catch errors from a JAX request. It's a normal practice. It's everyday practice. Or for and right now, any user it knows what to do. Must press reload page button. It's like universal solution right now, and it doesn't show our web as a stable platform. It could be a stable platform when you must press reload page every day. Other problem: you open website, you like fill a form, then press save, and unfortunately you must wait until loader will finish your work. But why? Why I can open a next document and fix it? Unfortunately, this is a normal user experience on most of websites, including mine. But we need this loader only because it is possible to have some problems. But unfortunately, like 99% of the websites of the request will not have any problems. But we still have this loader. Why? It's not useful. Or my favorite problem, like you open a document, and in the next second, your friend open the same document. You change a time and save it. And then your friend change a name and save it. But unfortunately, because we always send a full state of the document, the friend will overwrite your changes. It's like everywhere. We just don't care because like, it's not my problem. It's like he or her problem. But unfortunately, you always have two clients. You always must think about cooperative web interface, because like you have on every website, you have users with a phone, and so it's always two users in the project. So our web is not stable. We ignore the problem of the inconsistent networking. But I have a dream. Like before, when I go to sleep, I always dream about the better internet. I always dream that maybe in the future, all websites, not the special websites, not like chat application, like any websites that we have, will have real-time updates. When somebody changes a document, you will see it immediately. It's like obvious user experience. It should be for everyone, but unfortunately, we don't have it. Or it will synchronize the state in the background, so I can continue work while it's saving my work. Or it will have offline support, but offline support not by caching the data. Offline support, but give you ability to edit this data in offline and like go online after and like synchronize it without any problems. And I want this future without a lot of code, without extra code, because like nobody will have this future if you need to write more. We don't have time. Everyone want to go to bar, everyone want to go to dance, not to write extremely long code. And with existing ecosystem, because like if you will go to your DevOps team and like tell them, guys, we have a great idea, but we need to replace a database from PostgreSQL to some 0.03 database version, like they will kill you. This is a dream. Is it possible to implement? I don't know. Do I have a solution right now? I will be honest, not. But maybe we can create this solution. Maybe we'll create this solution soon. And I believe that solving this problem will be a next revolution, like revolution of 2018. So how we can solve it? Let's think about it. The main problem is Ajax. Because like Ajax is very easy when you have when you have easy tasks. But when your like complexity grows, Ajax become usable instruments. So we must kill Ajax. This is the only solution. Ajax is not working. Of course, I'm talking about web application. If you're creating some website, simple, Ajax is great. But for application, Ajax is not the option. We need to create something different. Current approach is like I have a JavaScript and have something else. I send a request to some unknown length, and sometimes this request will be returned. I don't care what is like besides my client side. But there is a better way to think about our system. It's called distributed system. This is like science, a lot of topics about it. But the idea is that every component of your application, backend, client side, and like both clients, both browser tabs, they're all part of the one system. And we don't send a request, we synchronize the states. This is the idea of distributed system. And unfortunately, distributed system is a little complex. It's not what we want to have in the front end. But there is a solution to solve a complexity. Do you remember, like about 10 years ago, with like PHP websites without any framework was like extremely complex and unusable. But then we got Ruby on Rails, and everything became better. Or like before React, how difficult it was to create a single web application. And right now, it's not a problem. So if we're creating some other framework, it will solve our problem with not working. But this is a problem. What is framework? What we need to create? I don't believe that framework is a code. Ruby on Rails is not a code located in the GitHub Rails. React is not a code located in GitHub, Facebook, React. Framework is the idea. When you agree with the idea of getting real, you will write a Ruby on Rails on any language. If you agree with the idea of reactive component updates, you will write a React on any language. And same with Redux, it's only idea. Code is like second. So we need some great idea. And we find it. We found it in St. Petersburg. After Meetup, very similar to this one, we have a lot of drinks with Dan Abramov. And we talk about very interesting problem. It's problem of merging conflicts. When you have two users, they change one document and then save it. Right now, current approach, we send a current state of this document, like change the document. But how to merge it? Of course, we can't write algorithms. But come on, nobody, like it will be a hell or not the algorithm. And if you have a problem with algorithms, you must change the data structure. Can we change the data structure to merge these conflicts better? And there is a solution. Of course, it's not mine, like the solution is 20 years. The idea is called event sourcing. We don't send a state, we send a changes, actual actions from users, not a diff, like it could be more complex changes. So it will be an initial state, like post title and likes count, and then one client add one action, second client add other actions. We don't need to write algorithms to merge these changes, because like the only thing that we need to do is to take these two arrays, concat them, and sort. That's all, the only algorithm that we need to fix conflict in event sourcing. And there is a good science project, it's called CRDT. It's a research paper about conflict-free replicated data types. It's data types with a lot of limits, but if you agree with these limits, they will not have any conflicts. They will fix any conflicts automatically, like in the terms of these limits. And the best CRDT is a Swarm.js, like best CRDT implementation in JavaScript is Swarm.js, written by mad Russian scientist Viktor Grishenko. But, so, when we drink with Dan Abramov, we think how we can combine Redux and Swarm.js. And we find that it's extremely hard. And the real problem, because we have like a CRDT is use that actions log, the list of the changes. And we have the same list of the changes in Redux, We have a list of the changes in GraphQL implementation, and we have a lot of implementation with a list of the changes. But it's always a separated tool, and we have a separated list of the changes in every tool. And this is why all the connection is very, very complex. And it was the idea. This is the idea of Lagax, to have one single log for any our tool. One log for Redux, one log to CRDT implementation, one log for synchronization process. Everything in one single log. So, how Lagax idea looks like. On the client side, we have a list of the actions called log. Actions is like the same action that you already have in Redux, with a type, everything same. But we have a same list of the action on the server side. And then we need only one thing to do. We need to synchronize it. We need to open a WebSocket, and when client will add a new action, we will send this action by WebSocket to a server. And of course, if a client will go offline, like all actions have a number, index, and on the connection, server will tell the last synchronized index. So synchronization is very easy. We don't have a duplicates. It's very stable synchronization. But also, we can create action on the server. And in this case, it will be sent to a client again. But also, this action could be created by other client, sent to the server, and then to our client. So this is a real-time updates out of box, just by idea. But also, if you will open your websites in a different browser tabs, all of these browser types will be a separated client with cross-client synchronization. So if you add action to one browser tab, it will be immediately open in the next one. So the idea of Lagax, put action to the log and forget about it. Don't worry when, how it will be synchronized. It's like deal of Lagax. Don't worry about user interface. Everything will be done by Lagax. The only thing that you must care is to put action to the log. That's all. What we have? First, like right now, when we have some changes, we send it to a server, and until the answer, we don't update interface. In Lagax, because you don't care about when it will be synchronized, when you add some action to your local log, it will update your interface immediately. You don't need to wait answer from the server. Optimistic UI, out of box. And for Lagax, we have a special library with all user interfaces, like all the notifications about synchronization process, all that stuff. And if you will have some problem, like you change a name, update interface, send this name to the server, and unfortunately server will have some error, server could send undo action to a client. And in this case, this action will be undone. And interface will be updated to the previous state. This is the idea. Idea is always great when it is in your head. But when you start to implement it, it becomes more complex. For example, first problem. We have two clients, and the order of the action in our log is extremely important. If you have a different order, it will be like disaster. There is no way to fix it. It's like more easy to remove all your system and start again. It's a main problem distributed system. Never order should be the same always. So we need to sort our log by some property, for example, by time. But time is not. It's not a simple thing. There is no distributed time. Like there is a series that it's impossible to create a best distributed time. For example, if you create two times, like timestamps, it could be equal sometimes, like because processor is very fast. Or my favorite one, sometimes a timestamp created after the first one will have a lower number than the first one because of time synchronization process. This happens. And of course, difference between client and server could be extreme. It could be more than 1 hour. Of course, timestamp is time-free data type, but some clients, when they go to a different time zone, they don't change a time zone. They change a time. And they start to have a very big difference with your time. So very complex question. There is a solution, it's called vector clock, but unfortunately vector clock doesn't work very well in the long offline, and also vector clock is not connected with the real time, but we create logax for everyone, for like, not for special developers, but for any developers. And so we must take care about, I don't know, getting a month number or weekday number. So in logax we have very complex time. First we use timestamp, then we use unique node ID, and the special counter that increase if you have two time with same timestamp. And to fix a problem with time difference between server and client, server on connection send current time, and client calculate a time difference and apply this time difference to any action. So you always have your log in your current machine time. So like logax time is nice, use it. Second problem. This problem was just 2 weeks before main introduction of logax in the React London. And I found that if you will open your website in 2 browser tabs, they will both use one index database. And so when they got action from the server, one of the tabs will think that it is duplicate and will not process it. And you know, it was the last thing. I was just, oh, I can't do this anymore. But sometimes your problem could be converted to your benefits. This is why you should not be scary about writing a code. And we find a very great solution. We browser tabs, when you open 2 browser tabs, they will elect a leader, and only the leader will keep a connection to the server. And so second tab will get actions from the leader. Of course, if you will close leader, they will start reaction again. It's algorithm close to the Rift algorithm, but like simplified. And finally, we have same state on every browser tab. We solve this problem finally. So it was ideas, but like let's see how code works, how code looks like. So we have logax Redux, and it's like without including Redux, it's only 12 kilobytes thanks to size limit. API is pretty same. You just need to replace create store with some additional code. And of course, if you have a friend who don't use Redux, it's not a problem. There is a low-level library. So you still have a same dispatch method. So logax Redux is completely equal, have same API, completely compatible with simple Redux. So you still have a normal dispatch method, but with logax, you have 2 additional methods, cross-tab and sync. First one, create actions that will be visible on the both tabs. And the second one, but when you add some actions, you need to sync when you will remove it. So this is the difference when you use cross-tab actions. And the second one, dispatch sync, will send immediately the action to the server, or like when connection will be when a client will have connections. So instead of making a JAX request, instead of thinking about loaders, catching errors, all this hell, the only thing that you need to do is dispatch one actions with one single word. It will be sent to the server, and this is a tricky thing. You can't use PHP right now. You must use a special Node framework like logax server to write a Node.js server, which will keep WebSocket connections. In this server, you will dispatch methods. You will have access control list and like process. And in process callback, you can do anything that you want. You can use any database that you want. And also, if you have a legacy PHP or Ruby on Rails backend, you can just send a RESTful request to them, like make a proxy from your server. And on the server, you can always create add action to a log and send it to a client. And on the server, you can always undo any actions from the client side without any problems. But returning to the client, in the client, you have a special library called logax status that will change your favicon, show warning, and like all the notification areas. About data access. we have a special subscribe method and like decorator. And if you have some component that require data from users, for example, you just use this decorator and subscribe this component to a channel name. And on the server, you have a special callback, check access, and then put to a log for client any initial state that you want. And like final things, scaling is not a problem. You just use same database and ping each machine on the new actions. That's all, that's a big deal. So this is Logax. This is how it works. This is how it works right now. But there is a few details. First, Logax is not a database. Logax is not a CRDT implementation. Logax is a framework to make database or to make a CRDT implementation. And second way, don't use Logax for simple websites, because the main problem in Logax is log cleaning. Sometimes it's really complex. And also Logax is complex. So if your website is very simple, if you will add Logax, you make it more complex. It's not the way how we write a code. But if you have a very complex site, a complex application with many crazy things, you will understand that you need Logax because you feel pain every day with writing all this code. And the second problem, Logax is not ready for production. Of course, we have a big experience with post-CSS and the prefacer. We know what a really production-ready means. So it's not production-ready in like a real world. But I recommend it to use only in your pet project because current version is 0.2. But we use it in our production because of our brave managers. Technically, they don't have a choice. And it's not a single-man project. We have many developers across the world. It's more than 30 contributors. And so, result of Logax. Logax replaces AJAX request and RESTful. It replaces it with log synchronization of the Redux actions between client and the server. This is like what is Logax is. Logax is not just for chats, just for like collaboration tool. It's for any complex web application. When user edit a lot of data, if your user don't edit a lot of data, just use GraphQL, it's better. Why? You don't need any loaders, you don't need any sagas, you don't need any mutations, you just need the old Redux actions. That's all that you need on the client side. Second, the reason why to use Logax, your interface become faster. Not the real fast, it is a fake, but user will be happy because when they click on the save button, it will be immediately saved. And so it's, wow, it's so fast, but of course not. Of course it becomes synchronization, but user will not see it, so it's not our problem. And of course, Logax have left updates out of box, offline first, all this shiny new things, and of course, compatible with existing ecosystem. That's all. This is a Logax Twitter, this is my Twitter, and my company Twitter. Thank you. Sure.
Let's do one fun thing. Never done this before?
Nah.
But let's do a selfie with everybody. All right. Raise your hands. Cool. Great. Thank you. All right. Thank you, Andre. It was a really nice talk. Hope everybody enjoyed it. If you enjoyed it, you can clap again. Now, just a minute to prepare the second talk, which will be also presented from the same laptop.
Awesome. Does this work? Yeah, this works. Okay. Oh, clicker. Okay.
Right. Welcome, Dario.
Okay, amazing. All right.
Zuber.
Hi, everyone. Hi, everyone. Welcome. I'm Dario. This talk is titled Hot Reloading in React, What They Did Not Tell You. The purpose of this talk is to give you an idea of how it works, hot reloading in React, when it works, and more importantly, when it doesn't work. In my experience, sometimes it can be quite frustrating or confusing to see errors pop up when you implement hot reloading in React. And I just want to give you a little bit of an insight on possible issues and how to avoid those issues. So let me start with introducing myself. I'm a full stack engineer at Suver. That's mostly on paper though. I mostly do front-end stuff. I've been doing front-end stuff for roughly 10 years now. I have a lot of opinions. I'll give them for free. Suver pays me to give them. And I'm here because Robert asked me to do this talk. Robert is also my manager. So thanks for the invitation, Robert. So this talk, it's about hot reloading, which is a magical, amazing concept in theory. However, it turns out that it's maybe a little less amazing in practice. Again, it can sometimes be quite a confusing thing. I often see people use it, and then a couple months in, they decide it's not worth the effort. It's actually slowing me down. So before we start, I would like to get a little bit an idea how you all feel about hot reloading. So the first one is, who of you have never bothered to set it up or never had the time or anything like that? Can I see some hands? Okay, so most of you have worked with it. How about the people that use it but refresh anyway all of the time? Yeah, figured as much. How about the people who've actually like turned it off because it started to annoy them? Still, okay. And how about the people who are infallible magicians and have it working all of the time? No one, right? Oh, we have a liar. Okay, we have a liar. All right. So yeah, first maybe explain what hot reloading is. So this tweet is pretty. Yeah, it's a pretty historical tweet. It's by Dan Abramov, the original creator of React Hot Loader. It's over 3 years old now. It basically says, check this out, I'm live editing a React app without refreshing. So that's it. Now seriously though, the idea of hot reloading is the ability to replace code in a system without actually shutting the system down or restarting it. And in the context of a web app, which is what we're talking about today, it means the ability to re-render your application without actually having to do that full page refresh. And what it means in the context of a React application is that you will have the ability to re-render the application without losing local state. Why do we want reloading? Well, the main thing is faster feedback. You can go from a normal development process where you have feedback from anywhere between 3 to 4 seconds, maybe even more, to getting feedback in like half a second. That keeps you focused. For me personally, if things take longer than 3 to 4 seconds, I lose focus. Like I look at my phone, I look at a different tab, and things that should take me like a couple seconds will end up taking me a minute. So it definitely helps to see the changes almost immediately on your screen. And another thing is that we're able to maintain state. If you have something that you're testing on that requires you to do an amount of user interactions, for instance, you're testing a form or you're styling a form or whatever, it can be quite cumbersome to have to deal with the fact that for every change you make, the browser will have to do a full page refresh, and you will have to repeat those actions. Yeah, it can slow you down, and that's not what we want. So what we want is productivity. As far as the building blocks for getting hot reloading to work in React, one of the things is Webpack, which is a code bundler that probably most of us use and definitely most of us complain about. Then we have Babel, which is a JavaScript compiler. It's mostly used for compiling newer features of JavaScript into a subset of JavaScript that is supported by older browsers. And we also have React Hot Reloader, which is the library itself, of course. As far as Webpack, well, yeah, just a basic introduction. Webpack bundles your code. That means it collects all your JavaScript files and emits one file that you can ship to your users. It also has a watch mode where files are being watched for changes, and on every change it will emit a new version of your bundle. And it also has something that they call the hot module replacement mode. Now, I wanted to do a really thorough explanation of what module reloading exactly is, but it's actually quite a simple graph on the old Webpack website that explains precisely what it does, and that's this. Now, I don't know about you, but I could look at this for 2 years and I still would not understand what this means. But I did the work, so I'm gonna try to explain it a bit. So the way that it works is when you enable hot module replacement for Webpack, is it includes a small piece of code that when your browser executes it will open a WebSocket connection to the Webpack process. When Webpack sees a change coming in, it will actually send just the changed modules to the browser, and the updates will be received by the browser. They bubble up in the sense that if you have module A that imports module B, if you don't accept it in module B, it will bubble up to module A. And if no one accepts the update, the browser will do a full page refresh. And this is basically how it looks. Check for the existence of the hot module replacement API in the module object. Tell Webpack to accept updates for the app folder. And then in this case, we refresh the browser, which is obviously something that we want to avoid. But just to give you an idea of the concept of accepting hot updates. Then we have Babel, which is, again, mostly used for compiling newer JavaScript into older JavaScript, so to speak. It's actually much more than that, though. It has a plugin architecture that allows you to do basically everything you want with any JavaScript file. It will allow you to edit, to make changes, to add code, to remove code, etc. It's like super extendable. So just to give you an idea of what's possible with Babel, there's this plugin. I'm just going to read it out loud. It's Babel plugin transform React pure class to function. If you're not familiar with the Babel plugin ecosystem, it seems like it's sort of a sport to come up with the longest names, and this is definitely a contender. But the idea of this plugin is to traverse your module, try to see if it can find a class component that only has a render function, and then it will change that class to a functional component. I'm not sure what the exact idea behind it. Could be something like file size, could be something like performance. But just to give you an idea of what's possible beyond just compiling new to old. And as for React Hot Loader, the library itself, that was originally written by Dan Abramov a couple years ago. And I think some other people took it over now, and they just released the third version. Version 2 and version 1 were even worse. The slogan is tweak components in real time, and I think it's very significant that they say tweak. Like, they don't say change, they don't say do a big refactor. If the scope of your change is like small, you'll be fine. But anything else than that, you'll have some issues. So what the library does is it will help us re-render the UI after an update, and it will make sure that the latest version of your component is actually rendered. It also helps us keep local state. It comes with a Babel plugin, which I will explain in a minute. It comes with a small runtime that you have to include in your code. There's also a use case without Babel, with just Webpack, but that's so limited, it's not even worth discussing. So this is how it looks. This is how a basic React hot loader setup looks. So obviously we have the basic React tools to render the application, and then we import the app container, and we create a render function to render the actual application. And as you can see on line 7, we actually require the module over there, and that's pretty important, and I'll get back to that in a minute. And the last thing that we need to do is, we need to accept the hot update for the app component, and then re-render the application when an update comes in. And another part of React Hot Loader is the Babel plugin that they provide. The goal of the Babel plugin from React Hot Loader is to basically find every component that it can find inside of your code base. So the way that it does it is it traverses your modules, it finds all the top level variables. So for instance, here we declare the foo and the bar component, and React Hot Loader will add a small piece of code that registers those components with their ID and their file name with the runtime. And the next step is, probably the most complex part, is the hot loader runtime. So you have to include a small piece of code inside of your application. It has a component registry. Again, it has those components matched by file name and ID. Whenever a module is executed, the components will register with the runtime. At that point, the hot loader runtime will create a proxy version of that component. So it's not actually the component, but it's something that proxies to the component. And this proxy, it can update a component type without unmounting the component. What normally would happen inside of a React application, the way that React works is when it sees two different types and it checks that by identity, it will unmount the component. But the proxy component makes sure that the identity is preserved of the earlier version, and you will be able to update the class of a component without causing an unmount, which helps us maintain local state. And last thing that it does is it overrides create element, which is a React function. If you don't know what that is, it's basically something that you call every time that you write JSX. There's actually just a react.createElement call, and it will return the proxy for a type if it has that type in its registry. And as far as handling the update, so first off, Webpack will send that update to the browser. The app will accept that update. It will re-require the module to make sure that the module is executed and the component is re-registered. And when the component is re-registered, the proxy component will be updated with the new version. And when the next time when the application is rendered, which is something that app container takes care of, we will render the new version of the component. And then it works. It's magic. You feel amazing, you feel productive, you feel the best developer in the world, but all of a sudden you notice that something is wrong, like some things are missing, like I didn't expect this. And you open up the console and you see all kinds of red errors. I'll just refresh just to be sure. So what does not work about in React hot reloading? The first thing that doesn't work is async arrow functions. An async arrow function is a class property, just like any other arrow function. And the Babel plugin does some weird stuff with class properties. That has something to do with the way that React proxy works. But in any case, the end result is that it's not reloadable. It's ignored. If you update an async arrow function, you won't see that change in your browser if you refresh the page. And you can sort of see it over here. We have a foo function that is an arrow function. It references a class method, and then you have an async arrow function that is actually left alone. So React will never see the update. Another thing that doesn't work, so apologies, is code splitting. So for those of you who are not aware of what code splitting is basically a way to split up your JavaScript file into smaller files. Like especially if you work on a larger application, you can easily ship like a JavaScript file that's larger than 1 megabyte. At that point, you'll have to use code splitting to split it up in smaller files. And Webpack will load those files for you on demand. The problem though with code splitting is that the updates will only bubble up to the split point. So if I define a split point in module B for module C, and I import module B and module A, I hope you can still keep track. But the update never gets to module A, and we don't know how to re-render. And just to give you an example, this is how code splitting looks in the context of a React application. We're using a helper library here, which is React loadable, to create a lazily loaded component. And the important part is on line 5, where we have the dynamic import statement that imports the module on demand. There are ways around this. There are ways to deal with it. What I see people doing quite often is to add synchronous require statements in development mode for the modules that they have code split. That makes it work. Like that tricks Webpack into thinking that it's one big chunk, and the update will bubble up correctly, and you will know how to re-render. And the other thing is that we did at Suva is we wrote a Babel plugin that actually adds a regular import every time that it sees a dynamic import, again in development mode. Sorry, I deleted the code. Anyway, let me go back. Anyway, so that basically just replaces dynamic imports with an immediately resolved promise that is the result of the static import. Another thing that is really hard to get right, and it makes sense that it's hard to get right, is lifecycle methods. So you have lifecycle methods like component will mount, component did mount, the constructor. They are obviously not called if a component stays mounted. So if you change anything within a render method that depends on changes in the constructor or component will mount or component did mount, like that could break your render method because the lifecycle methods are never called. And the only way out here is to refresh, like there's no way around it. If you want to keep local state, you won't have the updates in your lifecycle methods. Another thing that breaks quite easily is functional composition. Functional composition, or also known as higher order components, is basically a function that returns a component that renders another component. It's a pattern that's commonly used in Redux, React Router, Relay. Like the prime example is the connect function from React Redux. The problem is with it though is that it hides components from React Hot Loader. React Hot Loader can only see the top level variables in your module. And if you have multiple layers of composition, then React Hot Loader can no longer see certain components, and it will cause issues. So here we have an example. So we have the foo component, and then we have the connected component with 2 layers of composition, which is the connect function and the with router decorator, which you might know from React Router. So what happens in the output is that you can see that there are only 2 components being registered with React Hot Loader, because it's not able to tell that the argument that you pass to the connect function is a component as well. And the effect that that will have is that the component will be unmounted and remounted when you re-render the application, because the hot loader runtime does not have a reference to this component. The way you can work around this is you can, of course, you can declare a top-level variable for every phase in your composition. Yeah, that requires you to update your modules to actually make that work, of course. There's also a plugin I found out a couple days ago. It's called extract-hoc. It basically does the same thing we just described, but then automatically. And this is how it looks. If we go back to the previous example where we declared 1 component and 2 layers of composition, you'll see that it actually declares 2 different exports for both phases of that composition. And this definitely helps with making sure that functional components maintain state as well. And some other tips. The first thing is make sure that the errors that you get are visible. So when the application re-renders, catch that error and do something with it. Like, it doesn't really matter what. Either refresh it, or you can add a component like Redbox, which overlays a big red layover with the stack trace, but at least make it visible to keep you aware of the fact that something has gone wrong. And another thing is functional components are your best option. Like, if you change a functional component, like, there are no edge cases, it will just almost always work. Also, hot reloading is great for style guides. Like at Silver, we use style guides, but I think you can use things like Storybook as well. Just a focused environment where you only have logicless components, like just dumb components. In that context, it works great. If you want to add state and logic, you just do it in the context of your application. But at least you can do the styling changes within the context of your style environment. And last thing is avoid hot reloading as a whole. For some people, it might not make sense to use hot reloading. If you don't have server-side rendering, if you have a fast rebuild, if you have a fast reload, you might just want to avoid it, because if you can get consistent feedback within 1 second, you'll still be fine, and you might not need it. And I think that's it. Do we have time for questions?
All right. Thanks a lot. Let's do maybe one question. There was somebody saying that hot module loading works for him. Maybe
nah,
you don't know something. Maybe we're missing something.
Nah, I think he's lying. You're lying, right? Oh, okay. Well, I'll get back to you then.
All right. So that guy who fixed it can earn millions, I believe now.
Yeah, I think so. Okay, so that was it. Thank you. we have job openings at Super. Like, we're really fun to work with. Great place for talent.nl. Follow us on Super Engineering. It's not much going on, but we'll make sure that it's active somewhere. Somewhere. And follow me as well. Yeah, or not. Like, I'm not really active, but if you want to, you can follow me over there. So that's it. Thanks.
Right, so now we'll have a short break. We'll have basically a 10 minutes break. Be back here like in 13 minutes. We'll then have 2 short talks, 2 by 15 minutes. And yeah, grab a beer, run to the toilet. And I need to invite 2 speakers, the next speakers, to check the second laptop as I didn't find one. We're starting in a minute, so please take your seats. Like, take the seats that are available in front.
Does it work? Oh, I can't hear anything.
All right, so yeah, we're starting for the second part.
Trusting that it
So yeah,
works.
last seconds to take your seat, and we're welcoming the first speaker.
All right, I can start, right?
All right, great.
So, hello, my name's Ludovico Fischer. I'm the author of a book on React for pragmatic bookshelf called React for Real. But today I'm going to talk about render props. I have to apologize because I sent the wrong word to Robert in the title. It's not render methods, but it's render props. So how did I come to this subject? So while I was writing my book, I noticed that a lot of people have a few issues understanding Redux. So, sorry? Oh, scaling the font, yes. Yeah, so everybody likes Redux, but sometimes the API is a bit difficult to understand. There's a few reasons for that. One of the reasons is the usage of so-called higher order components. So you have a function that takes a component, in this case a component checkbox, and returns a new component. And inside the new component, you will pass some props that you extract from the Redux store to the component that you pass to the connect function. So it's already a bit complicated to explain. It's also a bit strange to read. So people have a problem understanding this. But a few days ago, I came through this post by Michael Jackson, who's the one of the creators of React Router. So he's not the singer, right? And he says, use a render prop, and he claims in this post that render props can replace higher order components everywhere. So I said, well, maybe let's try this. Maybe it will help make the React Redux API clearer. So I tried working with render props. So what is a render prop? It's just a function that you pass to a component as a prop, and this function tells the component what to render. So inside its own render method, the component just calls the render function that you pass as a prop. So we can create a class called connected, and this has a render method it takes the Redux store from the context. Well, it really doesn't matter where it takes it, but in this case, I take it from context like the existing React Redux connector, and then it calls a render function that you pass as a prop with a store state and store dispatch. So to go back to our previous example, the actual implementation, so I guess I have to increase this too, would look like this using this new connected component. Instead of creating a new component with the connect function from React Redux, we just use the checkbox component directly. And then we place this connected component, and we say when you render, use the checkbox and just pass the store state and the dispatch function as the props to the checkbox. So we can see that what's changed is now we have the configuration for the checkbox component doesn't happen inside some function in another file, but app happens at the call location. So in a sense, it's more transparent because you don't have to wonder where does this component takes its props from. It used to be based on checkbox that needed on change and checked, but it doesn't take them from anywhere, but it takes them from the store. But the fact that it takes them from the store comes from the implementation of connect function. So here everything is explicit. But of course we have another problem that we have this connected component basically everywhere. So every time we want to render a component that's connected to the store, we have to place it inside this connected component. And also there's something that doesn't quite work right, because usually in React you compose components, and here you have a component, and instead of having a child component, really, it takes a function that returns a child component. So if you look, for instance, in the React Dev tools, it's not as clear what is going on. So maybe if you look at the source code, it's clear, but not in the dev tools. And also, the final thing is that all these different composition methods have different behavior. So this is a guy called Alex Krolick, and he made a page where he compares different composition methods. And you can see whenever the color changes means the browser is redrawing the tree. And you can see that depending on the method you choose, you can have a redraw or not. So even though they should be functionally the same, they actually don't render the same way. So in the end, I'm not sure I'm going to pursue this and make this into a real library, because right now the examples I've shown don't work. So there's some implementation missing. But I hope maybe this has give you some idea. Maybe we can talk after the pause and see what you think and whether you think it's something worth pursuing. So thanks.
Thanks a lot, Federico. Now we get our fourth and final speaker for today, Bart.
This is better, I think. Yeah. Hello, everyone. My name is Bart Waardenburg. I'll be the final one and the last one between you and the bar. So I'll try to keep it worth your while. I work as a developer, a front-end developer at ANWB. I think most of you around here know that company, but for the ones from other towns and villages across the world, we are basically AAA, as in the United States, or the ADAC as in Germany. We're a motoring club. But today we do all kind of stuff. We have a shit ton of web apps and apps all over the place. And that's it. What do we want at ANWB? Our stakeholders, they want this. They want us to deliver high quality applications for our users while regularly releasing new features, which is basically, I think, what every one of your stakeholders wants from you. So nothing new there. But how do you do that? How do you get to that point that you can deliver high quality and still keep a nice pace with delivering new features? One of the things you can do to make that happen is to have a code base with a lot of tests. That's why I thought about giving a talk about how we handle testing. First of all, I think it's really hard to figure out when to write a test, when not to, all those kind of stuff. So when I looked at our code base, I thought, hey, we basically have 3 kinds of tests scattered around. And so I thought of the title, we have 3 layers. But as you might have guessed, when I started writing this talk and preparing, I noticed that we actually have 4 layers. So let's start with the first one. We'll be going through the pyramids from the bottom to the top, and I'll quickly show a small example of how it looks, and hopefully at the end of the talk you have an idea about how you can handle your testing in each of those layers. So the first one is static analysis. This is the layer that I thought of all the way on the end. Well, what's static analysis? Static analysis is the analysis of software that is performed without actually executing programs. Examples of static analysis are, for example, linting and types for JavaScript. Well, let's show some hands. Who uses linting in their development workflow? Nice, most of us. And another one who uses types for JavaScript, like Flow or TypeScript. That's a bit less. But anyway, those are 2 kinds of ways to improve the quality of your code and to make sure that the thing you deliver is actually that what you want it to be. I just noticed this today. There's some research done by, I think, University of London together with Microsoft, which had this conclusion: using Flow or TypeScript could have prevented 15% of the public bugs for public projects on GitHub, which I thought was pretty massive, since it's not really that big of a step to introduce it in your workflow. This is a small example of using, in this case, Flow to make sure there are no bugs in your React components. Let's see, how does on top here, I have a type definition for the props that I'll be using in this small button component. It basically says it has 1 prop, which is text, which should always be there, and it's a JavaScript string. Here's the component, and what it does, it puts the text inside the button. But what happens here, someone, or me, is using the component somewhere and is not passing a string, but is passing an array, which would cause some kind of error. But Flow or TypeScript would be able to catch that error and tell you even already in the development workflow that, hey, we're expecting a string, but you're passing an object, or array in this case. Go fix it. But you can have every single variable and function completely typed and linted, but still have none of your functions doing what they should be doing. An example is this. This is just a simple function which should multiply two numbers. I've got it all perfectly annotated with flow. The types are correct. The thing it does, it returns a number. But when you look closely, it doesn't multiply, but it does an addition. So linting would say, oh, no problem, it's perfectly fine. And flow would say, yeah, great, go ahead, push this to production. And that's where the second layer of testing comes in, which are unit tests. And who here writes unit tests for their code? Hands. Wow, that's quite a lot. That's nice. Well, basically, a unit test is a way of testing a unit, the smallest piece of code that can be logically isolated in a system. To make it a little more simple, it's testing whether a function does what it should be doing. There are several ways to do that. Here I have taken the multiply function I showed earlier, still doing the wrong thing with addition. And I've written a simple test using Jest, but any framework can do these kinds of things. This is a really simple function. So I can just say, I expect a multiplication of 4 and 3 to be 12, which I assume is correct. If you run it in Jest in your terminal, you will see that it expected to be 12, but we did an addition, another multiplication, so it returned 7, and it told you to go fix it. Another really cool, relatively new way to test your code, and especially useful for testing React components, is snapshots. And a snapshot is a test that verifies that a piece of functionality works the same as it did when the snapshot was created. It's like taking a picture of something and doing some changes in your code and taking a picture again of that same piece of code, or better to say the output of your code, and comparing those two. So for example, I have here again a simple button component which takes a parameter with a type, which should be a string. It makes that into a class name. And in here we have the snapshot running. It uses a helper function created by the React team to turn a component tree into a JSON object. So the JSON objects can be stored, and next time the test will run, it will compare those two JSON objects and see if anything has changed. If all goes well, it says, yay, everything is great. But if it didn't match the new way because you changed something somewhere and it touched the code you've written, you would get an error. It says fail, and in the bottom of here you will see what exactly has changed. I have changed some code to pass the bad string instead of the good string, and it will display in your terminal or any other environment where you're running the test that it has failed. But again, you can have every single component and function unit tested, but you still have none of your functions working together like they should, because you're only testing whether they each separately do what they should be doing. Here I have a simple example. The multiply function is this time working correctly. I've got a simple alert number function which alerts a value, and I've built a button. And I wanted the button to alert a number multiplied when you click on it. But as you can see, I forgot to include the alert number on the onClick, but I did it on mouse enter. This would pass the unit tests. Snapshot will display, hey, it has an onClick handler, which has a function. It doesn't show exactly what kind of function it was, but it's there. Which brings us to our second layer, the integration testing layer. And integration testing is the phase in software testing in which individual software modules are combined and tested as a group. When you hear this, are there people who are using integration tests in their software who are building that? Quite a lot, nice, looking good. I think they're the hardest part to get right. So I write not a lot of them. The snapshots are easy, just write one line and it all goes great. But with integration tests, you have to think a lot more about things. And when you talk about integration testing while using React, Enzyme is probably the most popular and most useful tool. Here we have the same button component again, with the on-click and the on-mouse enter, and here in the bottom we have a test case, where we say the button component should run a function on click. And when we click it, in the test we use Enzyme to simulate a click. We want the alert number function, which we have mocked here with the jest helper, that just tracks how many times there has been interaction with the function, to assert that it has been called once. And when we run it, we'll see that it has failed because it was called 0 times. But again, you can have everything working together completely as intended, but still have an empty screen as an application. Let's take this for example. There's someone who wrote this beautiful piece of code which would hide the complete application. It could be some weird script someone left somewhere as a joke, or I don't know, but it could happen. That brings us to the final layer of the testing pyramid, which is the user interface testing. Who here writes user interface tests, are sometimes known as end-to-end tests or regression tests, quite a lot of people. Some companies have special QA engineers who write them. Some people don't do them because they're hard. User interface testing is the process of testing a product's graphical user interface to ensure it meets its specification. When you look at tools to do these kinds of tests, there are really a lot of them. I have listed here a couple at the top of my head, but there are even more. Probably the most popular and the oldest one is Selenium, or WebDriver, which has been here the longest, but people are not really happy with Selenium, so they're creating their own frameworks around testing. All of their ups and downs and good use cases and bad use cases. But the two I'm going to show you little short slides about are Navalia and Chromeless, because they bring something to the table that the others made a little harder or are just not that good at. This is an example of Navalia. Navalia uses headless Chrome to test your application or your web page, actually. And what we're doing here in this function is we use a library called just image snapshot, which does probably what you think it does. You can tell Chrome to go to your web page, to wait for a certain element to appear. You can have it take a screenshot, and after that you can check if that screenshot matches the previous screenshot. This is a little example of an application I'm working on. This is the AMB route planner, used by a lot of people who don't know how to find Google Maps. No, we do have things that they don't have. But anyways, I instructed it to do this. It took a snapshot. It said it passed because it was the first snapshot. And now I've run the code second time. And what it does, it compares the new image with the previous one, and it creates some sort of image comparison. And what happens when it fails, maybe someone did something that they shouldn't have been doing, it will say that the expected image did not match or wasn't a close match with the previous one. This example has a big, lovely cookie pop-up all over the application. And in the middle here, you'll see a small heat map, which displays the red things from this has changed. And again, just like with the regular snapshots, you can tell just whether that was what you wanted or if it wasn't. And the last cool example of a tool to do visual testing is Chromeless. And what Chromeless brings is it's a similar syntax. It's almost the syntax that's used on all other tools. But the cool thing it does, it allows you to run the headless Chrome browser in a AWS Lambda function, which solves one of the biggest problems with these kind of tests is that Selenium tests, for example, are really slow. They take a lot of resources, and it can sometimes take 20 minutes to complete all your tests if you have a lot of them. And with AWS Lambda, you can spin up as much functions as you want. Then when it does, it has a Chrome headless running there, and you can send your commands through the terminal to those instances, which will mean that you can run as many tests parallel as you want or as your computer can handle, which is quite a lot. And it's really easy to set up. Chromeless provides a serverless package you can set up by just entering some API endpoints and API keys. And then you can run hundreds of browsers in parallel. And you might say, well, that can get expensive really quickly. Well, it turns out you can easily run over 100,000 tests a month for free in the free tier, because those tests only take roughly 8 seconds a piece, and it just spins them up and it turns them down again when they're done. So it doesn't take that much time, and which is great. So this is the pyramid. It's complete. When you go up the pyramid, testing gets harder, or there are more things to worry about, but the actual value for your users also goes up, because with a perfect user interface test shebang, you can cover all the edge cases, and with just static analysis you can't. It doesn't mean that you don't have to do them, just know that they're all there. Thanks for listening, and happy testing.
All right, so thanks, Albert.
Yes.
Really insightful. By the way, anybody who had really successful experience with some of the end-to-end testing tools,
Yeah, I'm
reach
really
me
interested
because
in